Hi guys, let's review graphs of absolute values, and then we will be done with review and actually be able to do some new Algebra 2 stuff after this. So, what's an absolute value? An absolute value of a number is defined as follows. So this symbol, of course, means absolute value of x, and what that means is x is equal to x if x is greater than, absolute value of x is equal to x if x is a positive number. The absolute value of x is 0 if x equals 0. And the absolute value of x is negative x if x is less than 0. So if this was absolute value of negative 2, it would take the opposite of negative 2 would be positive 2. Okay? So basically, whatever comes out of here is a positive number. Now, it's very important that you remember you always do anything inside the absolute values before you take the absolute value. Okay? So here we got a couple of examples. The absolute value of 2 is just 2. The absolute value of 0 is 0. And the absolute value of negative 4 would be 4. Okay? Piece of cake. All right, now, graphing them. That's where people kind of run into trouble. So an absolute value will always look like a V. Okay? So with this one, this would be a simple one to just make a table. Okay, and if I plug in 0, I get out 0. Okay, absolute value of 0 is 0, so that's going to be a point right here. Let's try some positive numbers like 1. Absolute value of 1 is 1. That's going to be 1, 1. Absolute value of 2 is 2. That's going to go right here. Okay, let's try some negative numbers. Absolute value of negative 1 is 1. So negative 1, 1 will be on the graph. Absolute value of negative 2 is 2. That's going to be right here. So my graph is going to look like this. Okay? Now, here's the thing. I said every absolute value is going to look like a V. There's a V. If there's no sign out here, the V will be open up. If there's a negative sign outside the absolute value, the V will be open down. Okay? This point right here, which happens to be the origin, the bottom of the V or the top of the V, depending on which way it's oriented, that is called, whoa, get right today. That is called the vertex, capital T, capital V. Okay? That's the vertex. This has it's just like when we did quadratics. Okay, a quadratic is a U shape instead of a V. It had a line of symmetry. This has the line of symmetry. This has a vertex right here. That has a vertex right there. So it works the same way. Okay. Now, how do you find the vertex? Well, you find the x-coordinate by taking whatever's inside the absolute values and setting it equal to 0 and solving it. That'll tell you where the x-coordinate is. Then you can just plug the x-coordinate into the equation, and you'll get the y-coordinate. So let's look at this one. Y equals the negative absolute value of x. Well, here's the deal. If I make a table for this one, okay, and I plug in 0, negative absolute value of 0 is still 0. So I still have the same origin point here. Okay? If I put in a 1, absolute value of 1 is 1, but then I put the negative on the front, so that's negative 1. So 1, negative 1. I plug in 2, absolute value of 2 is 2, but I put a negative on the front, so it's negative 2. If I plug a negative 1 in here, I get absolute value of negative 1 is 1, and then I slap the negative on the front, so again it's negative 1. And same thing with negative 2. So you can see this just got flipped upside down from the last one. Okay? All right, let's look at this one. So if I make a table, I know making tables is not super fun. It takes a long time, okay? But I want to do it on the first couple so you kind of see why things work. So if I plug a 0 in here, I'm going to get absolute value of 0 minus 3 is going to be the absolute value of negative 3, which is 3. So if I plug in 0, I'm going to get 3. 0, 3. Okay. Now, if I plug in 1, I get 1 minus 3, absolute value of that, of course, which is the absolute value of negative 2, which is 2. So I get this. If I plug in 2, absolute value of 2 minus 3 would be the absolute value of negative 1, which is 1. Oh, I'm going to get that point right there. What if I plug in 3? Absolute value of 3 minus 3 is the absolute value of 0, which is 0. 3, 0. So I seem to be going just downhill, but don't give up, because if I put in 4, now look what happens. I get absolute value of 4 minus 3, which is the absolute value of 1, which is 1. Uh-oh. I've changed directions. Well, I found my vertex. I found the bottom of my V, so this thing's going to start going back up now. So I'll just do one more, although you probably know what the answer is going to be. 5 minus 3, absolute value of 5 minus 3 is going to be absolute value of 2, which is 2. So you can see the V here. It's going to look like this. Now, you can shortcut this. You don't have to do all this work. Just simply by saying, okay, I'm going to take the stuff inside the absolute value, set it equal to 0, and solve it. Oh, x equals 3. Hey, that's my vertex right there. Okay? And then I'm going to plug that in. I get 3 minus 3. That gives me 0. 3, 0. That's my vertex. Okay? And then I pick 2 points to the left, 2 points to the right, plug them in to a table, and I'm done. Okay? Now, I can also, once I find the vertex, I can look right here at any number in the front of this absolute value is going to be the slope of the sides. So there's no number here. That implies that it's 1. Okay, people think it's 0. It's not 0, it's 1. So the slope of one side is going to be 1. Slope of the other side is going to be negative 1. Okay? So let's look at another one here. Okay, what happens here? Y equals the absolute value of x minus 1. Okay, so if I go with what I did before, and I say, okay, take the stuff inside the absolute value, that's x, set it equal to 0, and solve it. Hey, x is 0. Okay, so my axis of symmetry on this thing is going to be right there. Okay, now if I make my table, and I plug in 0, I get absolute value of 0 is 0, minus 1 is negative 1. That's my vertex. Now look here, here's my slope. My slope is 1. This thing's opened up. Has a slope of 1 on one side. Has a slope of negative 1. Oh, that's terrible. Has a slope of negative 1 on the other side. Okay, if you go back to transformations, if I subtract a number from the outside of a function, all that does is move it down. If I add a number, it moves it up. If I put something inside the function, it moves it side to side. So here, if I put in, if this is negative, it moves it to the right 3. If it's positive, it moves it to the left 3. So I can analyze this graph and just graph it. Okay, this is always my basic one right here. Okay, it's my basic absolute value, and I just move that around depending on the transformations. Okay, the sketch of the graph y equals a times bx plus c plus d. Use the following steps. Okay, so you can look at this thing. Okay, remember I told you, you take this middle part right here inside the absolute value, set it equal to 0. You solve for x, and that's going to tell you the axis of symmetry. Then you're going to plug it back in here and figure out what the answer is. That's going to find the vertex. Okay, so find the x-coordinate of the vertex by finding the value of x for which bx plus c equals 0. Make a table of values using the x-coordinate of the vertex, some x values to its left and some to its right. Okay, so remember what I said. This will give you the x value. Plug it in, that gives you the vertex. Okay, which should be just adding this. This is going to be the slope of the sides. One side's going to have a slope of A, the other side's going to have a slope of negative A. Okay? So you can do it this way, construct a table of values using the x-coordinate of the vertex, and then some on the left and the right, and then plot the points on the table, then connect them with a V-shape. You're not getting a V-shape, you got a problem. Okay, so let's just look at this one. Okay? X minus 2, set it equal to 0. Solve it. Okay, my axis symmetry is going to be at 2. It's going to be right here. My vertex is going to be somewhere on there. Where's it going to be? Plug it back in. Okay, so negative absolute value of 2 minus 2 plus 3. Oh, that's going to be negative 0 plus 3, which is going to be 3. 1, 2, 3. There's my vertex right there. Okay, I can look at this. This negative sign tells me it's going to be open down. My coefficient out here, since there is no coefficient, that coefficient is 1. It means it's going to have a slope of 1 on one side. So it's going to look like this. You have a slope of negative 1 on the other side. It's going to look like that. There's my graph. Okay, let's look at this one. Use a bright and cheery green color on this one. So I'm going to take this, 2x plus 1, set it equal to 0. 2x is negative 1. X is negative 1/2. That's my axis of symmetry. So we're going to go, I'm going to get a nice axis of symmetry on this one. Okay, and that axis of symmetry is at negative 1/2. It's right there. Why was that? Okay, that's fine. It's black. Okay. Now, if I plug this in here, I'm going to get 0 here. So minus 4, that's going to tell me that my vertex is at negative 4. 1, 2, 3, 4. It's going to be right there. Okay. My coefficient out here is 1. It's positive. It's opened up. So it's going to go up 1 to the right 1. So it's going to go here, 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 here. And this side's going to go here, 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 here. Draw your V. Done. If you analyze it properly, it's a lot less work. Okay, I got a few absolute values for you to work on right there. Enjoy that assignment. I'll see you guys later.